Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Faris Hanuntiarso. My absent number is 32101811023, and I'm from Power Plant Engineering, Department of Mechanical and Energy Engineering, Electronic Engineering Polytechnic Institute of Surabaya, and I will explain my progress of final project with the title is Numerical and Experimental Analysis of the Effect of Jet Impingement Distance on Double Trapezoidal Absorber Plate Solar Air Heater. Background of research. The use of solar energy can be applied in many other ways, one of which is the use of solar collector or solar irradiator in the drying fluid. This tool utilizes solar energy in the form of radiant heat transfer, which is then absorbed by heat absorbing plate, which then exchanges with heat with the working fluid in it. One of the problems that occur in the solar irradiator is the low rate of convection heat transfer between the surface of the absorber plate and the air flowing on the top and bottom sides. Modifications made to the thermal efficiency of solar aerator are to increase and expand the area of the absorption area of heat energy. There are various types of modification, like the addition of plates, fins, obstacle, lips, and lips on the solar aerator. Then there is other way to improve the performance of solar aerator. This is the improvement is jet impingement. Uh, Jet impingement providing holes or gaps, and jet impingement is a heat transfer method in which the fluid is emitted through holes or nozzles to a surface or plate that has a temperature difference. Impinging here means collision, which is a collision between the coolant and the surface of a target at high flow rates. This method can also be used to heat a component or a certain material, like a food drying process. The analysis in this final project is carried out numerically by modeling DTIP-SEH in a combination of fluid dynamics, simulation, and experimentally by making DTIP-SEH and testing its performance in the laboratory with measuring instruments. The purpose of writing this final project is to find out whether the distance between of jet impingement has an effect on the performance and efficiency on DTIP-SEH. Goals of research. The expected goals of this final project are knowing the rate of heat transfer in DTIP-SEH with variations in jet impingement distance, knowing the characteristic of the airflow produced by DTIP-SEH, knowing the performance and efficiency of DTIP-SEH numerically and experimentally based on variations in the jet impingement distance. And this numerical flowchart for my numerical studies. And the first step is CFD literature study for solar aerator, and then second step is determination of condition or operating data, such as the first is velocity and pressure at inlet section of DTIP-SEH. In number two, intensity of radiation hitting DTIP-SEH, and the third is distance variation between jet impingement. After that, we can input geometric design of DTIP-SEH into ANSYS Fluent, and then we do mesh checking. After the mesh checking is done, we can do setting boundary condition and simulation setup, and after that we can do the processing stage. In the processing stage, we can input the value and data from the reference, and we can do the calculation. If the iteration is convergent, we can do the grid independence. Grid independence can make and obtain a better quality mesh, and after that we can do the validation of results, and we can do the validation with the formula from the reference, and after that we can do the simulation of distance variation between jet impingement on DTIP-SEH. And the last process is simulation data retrieval, such as counter of temperature, velocity, streamline, and flow vector. And this is pre-processing stage. There are fluid geometry of DTIP-SEH after the drawing in Autodesk Inventor. We can convert the geometry to the STL format, and then the STL format can be input to ANSYS Space Claim and Mesh Editor, and then we do the meshing, and this is the results of the meshing of DTIP-SEH. After the meshing is done, we can do the name selection or boundary we can do the name selection for the boundary condition. And there are 4 boundary condition in my geometry. There are heated wall, inlet air, wall, and outlet air. And then this is a table of setup or processing. The solver that I choose is pressure based, and then activate the energy. And the viscous I choose is RNGK epsilon, because from the reference of solar editor, many experiments or many experiment of solar editor many use RNGK epsilon. And the scheme is simple, and the discretization gradient is less square cell base, and in below is in below there are second order upwind for all parameter. And the initialization is hybrid, residuals is 10 power minus 4, and we can calculation with 500 iteration. And this is post processing of DTAP-ACH, and this is the counter of temperature, and figure shows the temperature condition of all DTAP-ACH fluid geometry. The area of higher temperature is located in the space between the absorber plate and the jet plate before the jet impingement is applied. The maximum temperature of DTAP-ACH is obtained in critical areas such as the upper end of the absorber plate near the inlet side with a value 603 Kelvin. The cause of the higher temperature in the space between the absorber plate and the jet plate when compared the other areas is because there is still no interaction or meeting between the air inside between the air inside and the air coming from the inlet side. The air temperature in the space between the absorber plate and the jet plate decreases when interacting with the inlet air flowing as cross flow through the jet impingement. If there is no further jet impingement underneath, then the air temperature in the space between the absorber plate and the jet plate will increase again in the range of 337 Kelvin to 375 Kelvin, especially in the area close to the boundary condition on the heat wall side. And this is post processing of velocity, counter of velocity, and the velocity counters obtained from the simulation results are divided on the plane with XY plane located in the Z position 0.3 meter, the YZ plane in the X position minus 0.45 meter, and the ZX plane in the minus 858 meter position located above the jet plate and jet impingement. And this is the XY plane and ZY plane, and the plane shows that there is an increase in velocity in the area near the jet impingement. And the greater velocity value as shown figure, apart from being near the jet impingement area, the velocity value tends to be normal at 0 until 2 meters per second. For the ZY plane, velocity values in the area near the jet impingement at the edge of wave plates. Wave plates number 1 and 9 are higher than other wave plates. The location of the greatest velocity value is appropriate in the space between the absorber plate and the jet plate above the midpoint of the jet impingement, like as shown is second figure. And this is the XZ plane is same like before. The jet impingement has increase in velocity, increasing, and this post processing of streamline. And the first figure shows that streamline contour on the side of the XY plane, where there is a backflow air circulating in the space between the jet plate and the bottom plate close to the outlet area. Backflow is created because there is a cover wall in the space between between the jet plate and bottom plate, so that if there is no jet impingement, then hot air will be trapped in the space and affect the distribution of airflow in DTAP-SH. And the second figure is streamline counter on the side of the ZY plane, where the airflow in the space between the absorber plate and the jet plate is also affected by the airflow that moves from below, originating from the wave side of the other plate, in addition to the influence to the airflow through the jet impingement. The flow is in the space between the bottom side of the absorber plate and the bottom plate, where there is no jet plate inside. And this is a velocity vector, and this is the grid independence. For the grid independence, the small error obtained by data tree with error is 0.0024%, with outlet temperature is